the context of this video is on solving equations and more specifically multi-step equations. And so there's two types of equations really here that you're going to see. You're going to see some one-sided equations, like what you see here, where you've got all of your variables on one side, and you've got another side where it's singled out. And then if we kind of move ahead a little bit more, you would see also some two-sided equations where you see there are variables on both sides of the equation. Okay, so our focus in this video is to look at how do you kind of approach these two types of situations, these two types of equations, and move forward. So let's kind of travel back to one of these or one-sided equations, excuse me. So a lot of these entail distributing, combining like terms. Some things to pay attention to would be the negatives. Those kind of always get in the way, and then how you actually go ahead and combine like terms. So, in this example here, you want to distribute first. You can never have parentheses left in an equation and start doing work. You need to have it so all terms are kind of listed out first. So I'm going to go ahead and distribute the negative 10 to both terms. And when I do that, I am left with three terms on the right-hand side. So I have negative 13m, positive 80, and positive 80m. So at this point, all my distributing is done. My parentheses are gone. And at this point, it's a term or a time to combine like terms. And so you're doing that in isolation of a side. So I am ignoring this 415, almost like it doesn't exist right now, because it's the only thing there. It's already simplified. I need to simplify the other side before I can move forward. So I'm going to combine my... in this case, those are the m's. So I'm going to combine the negative 13m and the 80m. When you combine like terms, you are looking to just do what you see. So if it were me, I'd be typing in my calculator negative 13 plus 80, because that's exactly what I see written straight across. So when you do that, you get 415 equals 67, and don't forget to throw the variable back onto that, and then plus 80. So at this point, this is a two-step equation, something that you've seen for many years. You want to isolate the variables. So to do that, you want to move your number over first, and that's because this is just a number over here. So if I subtract 80 from both sides, I get 335, and that equals 67m. And when I divide by 67 on both sides, m is equal to 5. And then the greatest thing about equations is that you can take that 5 and you can plug it in to the two m's and type it into your equation and your calculator and see if it comes out to be true. And if it does, fantastic job. So what I would encourage you to do is to try this equation here. I would encourage you to push pause, try it on your own, see if your steps match mine, and then push play when you're ready to check your work. So in this case, I went ahead and distributed the negative 8. Remember to use the number or the sign that's in front. Again, look to combine like terms. So I get 364 equals negative 30r plus 64. I'm going to go ahead and now solve this two-step equation. Make sure you divide by not just the number, but the negative as well. So you get everything to cancel. So you get negative 10 equals r. And again, you could always plug that number in to see if it matches. In this case, I want to do one more of these. And one, there's a step up in level. But two, because you get something interesting here. So when you distribute the negative 4 and the 5, and I'm going to do that all in one step here. I get 40v minus 44, and then negative 40v plus 45, and that equals 1. And the interesting thing that you see here is that when you go to combine your like terms, 40, if I do exactly what I see here, 40 minus 40 is equal to 0, which means the v's cancel, and they no longer exist. And then if I go ahead and combine my numbers, I get negative 44 plus 45. So let me write exactly again what I see. And that equals 1. So essentially what I'm left with on the left hand side is 1. And I also have a 1 on the other side. So in this case, this is a special case where this leads to infinite solutions. Which, remember, infinite solutions means that any number can be plugged in for these v's right here, and you'll always get the answer of 1 based on the makeup of the equation. Okay? And the red flag for that, or it all started in terms of my brain thinking, oh, I'm going to get a special case, happened when the variables canceled. So remember that when the variable cancels, you are looking at a special case, which in this case was infinite, and the reason being is because I was left with an equation that equaled each other. It was a true equation. Okay, let's go ahead and take a look at some two-sided equations real quick. So let's just start with this one. This is nice, not so intimidating. So in this case, everything really goes the same. You distribute just like you have been in all your other equations. And when you do that, you get 12 plus 96x equals negative x plus 12. Here's the thing when it comes to two-sided equations. At this point, just determine which side do you want the x's on and which side do you want the numbers on. And it does not matter. So by default, I usually like my variable on the left and my number on the right, but it doesn't matter. But I'm going to stick to that. So I need to move the x over here, and I need to eventually move the 12 over here. Okay? So I'm going to go ahead and add x to both sides. So when I do that, I get 97x equals, the 12 is still on the right, so that drops, and this 12 is still here, so this drops. And then to move my 12 over, I'm going to subtract 12 from both sides. And when I do that, I get this to cancel, and really this to cancel, so I have 97x equals. When there's nothing left on an entire side of an equation, it's just 0 that's there. So I can go ahead and finish this out and get x equals 0. I know that there's a misconception here that, you know, when you get nothing on one side, you're like, oh, it has to be no solution. But that's not true. I had a variable. I wrote a variable. Okay? So when you do that, that is an indication that you are going to get an answer, and probably most likely 0. All right? Let's look at one more. Let me see if I can find one that I really like. All right, it doesn't really matter. Let's do this one just for fun. So probably one of the most complicated questions. You'll get lots of things going on. So you could do multiple things first. You could go ahead and combine these like terms. You could distribute. And really, I'm going to go ahead and do all of them at once. So I'm going to combine the two and get 9r. Go ahead and distribute. So negative 96 minus 64r. Plus 91r minus 156. At this point, there's not a lot of first choices here. I'm going to go ahead and combine like terms. So I've got two r values, and I have two numerical values that need combined. So 9r equals negative 252 plus 27r. At this point, it looks like it's a two-sided equation. However, it's not exactly. This 27 is going to be the term that I move because 9r is already isolated. So I want to move the like term. So I'm going to subtract the 27. If I were to subtract to move the 252, it wouldn't do anything because it doesn't combine with 9r. So once I divide by negative 18, I get r equals 14. So there's my final solution. I want to backtrack and look at one more question. And I'm hoping you're thinking, oh, it's because it's another special case. And you're right, it is. I just want to show you what the opposite special case were to look like. So in this case, I'm going to go ahead and distribute on this last question to both of these terms. So negative 102 equals, let's see here, negative 104x, maybe, minus, I believe it's negative 117, and then plus 13 and plus 104x. So when you do that, you right away can see that the 104x is there twice, one positive, one negative, so that cancels that out. And then you're left with these two like terms in the middle, which when you combine them, ooh, did I do that incorrectly? It looks like no, I'm all right. Negative 104, I think that's correct. So the reason I wanted to show this is because it's an example of something that has no solution. And the reason is because this equation is not equal. Negative 102 is not equal to negative 104, therefore leading to the no solution, which is different than your infinite solutions when you had 1 equals 1. So I just want to point out what that would look like. Again, your variables would cancel, but you'd be left with an equation that does not equal each other, does not make sense. You're free to go through and do any of these other examples that if you'd like that are on this video, but that is all up to you. If you have any questions, please come see me.